Hey team, in this video we're going over surface area of prisms and cylinders. So basically, let's dive into the examples. Let's take a look at the first one we have here, which is a prism. And so here we have a prism with a length of 10, a depth of 4, and a height of 5. And so we're wondering how much, say this was a Christmas present, how much paper would you need to cover this box exactly, with no extra paper, no excess or anything like that? How much paper would have to be used? And so that's the idea with the surface area. And so one thing to remember is, let's take a look at the formula. So the surface area formula of a prism would be the perimeter times height plus 2 times a capital B. And this capital B we're going to call the area of the base. And so here you could say 10 and 4, this bottom part is the base. You could define this shaded side on the right as the base, and so then that means the left side would also be the base. And if you kept it where it's standing up straight, then 10 times 4 would be the base. Well, then of course the top side would be your second one. Okay, so for this I will say the bottom is our base, and so the area of the base would be length times width, a 10 times 4. Okay. So let's plug this in. So the surface area equals, let's see, the perimeter times height. So the perimeter would be 10 plus 4, and we'd have more of those as well. Let's draw that in, because we'd also have a 4 here, and we'd have another 10 on the very back. And so let's see, the perimeter would be 10, 20, and 4 plus 4 is 8, so it would be 28. So the perimeter is 28. The height would be 5 then. And then 2b, so 2 times the area of the base, which would be area of a rectangle is base times height, so that's 10 times 4 in this case. Alright, and there we go, we have it set up. And so you could do some mental math, you could type it in quickly. Let's go ahead and just type it in quickly. So we have 28 times 5, which is 140, and then you have 40 times 2, which is 80, so add your 80 in, and you're at 220 for the surface area. So surface area equals 220 centimeters squared. Alright, let's take a look at one more of these problems. Let's say we had this time a triangular prism. And, well, this one looks a little more complicated. So we have a base here, and I'm going to define the base as being the bottom again with this triangle. And then we have this kind of lateral area on the way up, and then our second base, of course, is on the top. So we still have this basic formula, surface area equals the perimeter times our height plus 2b. And this time the base is going to be this triangle. So the b, capital B, is going to equal 1/2, or base times height, over 2, because that's the area of a triangle. And so let's see, in our triangle here, this dotted line right here looks like would be the lowercase b in this, so it'd be 7. The height of that triangle would be 8.7, and then we'll have to divide that by 2. So 7 times 8.7, all divided by 2, would be our capital B. And so that's going to give us, let's see, so 7 times 8.7, and it would be like 60.9, divide that by 2. This is going to give us 30.45. So that's your capital B. Okay. Let's go ahead and find our perimeter. So we have 9 inches on this bottom side, we have 7 inches here, and then we have 10 over here. So 9 plus 7 is 16, plus another 10, that's 26. So your surface area, or your perimeter, is 26. The height of this would be 8, and then plus 2 times your 30.45. And so we have the perimeter of 9 plus 7 plus 10. We have the height being 8 for this triangular prism, plus 2 of our bases, so the bottom one and the top one. So let's go ahead and type this in. So we have 2 times our 30.45, so 60.9, right? And then 26.8, or 26 times our 8, 208, plus our 60.9. That will give us a total surface area of 268.9 inches squared. Alright, so 268.9 inches squared. So if we had a box shaped like this, that's how much wrapping paper you would need to cover this exactly with no overlap. Okay, let's take a look at a couple cylinders now. So let's say we had the radius of the base of a cylinder is 6 centimeters and its height is 15. What is the surface area of the cylinder in terms of pi? Okay. So let's get this over here. There we go. Let's take a look at the formula first. So the surface area of a cylinder would be this formula right here. We have 2 pi r squared times the height plus the bases again. And in this case, the base of a cylinder would be a circle, so it would be 2 times pi r squared. And so we have an error here. First of all, I'm going to get rid of the square. I was thinking ahead of myself. I will put the h back in. So 2 pi r h, that represents the circumference of a circle multiplied by your height, so it goes on up. And then here, 2 pi r squared would be the area of a circle, and you have 2 bases. So here we have our cylinder, and then of course the bottom base. So you have 2 of these bases going on here, and then you have the circumference, so you go around the circle, times the height, which of course would be there. Alright, so let's keep this diagram. The radius of the base of a circle is 6 centimeters, so we have from the center to the edge, that'd be 6 centimeters. The height is 15, so this would be 15. What is the surface area of the cylinder in terms of pi? Okay, well, I think we have enough information just with those 2 numbers. Let's go ahead and fill it in. So here we'd say it's 2 times pi times the radius, which was 6, times the height of 15, plus 2 times pi times 6 squared. Alright, so we just replaced all our r's and our h's with the numbers they gave us. So let's see, so we have 36 times 2, which would be 72 pi over here on the right side. And then 2 times 6 is 12, 12 times 15, you get, let's see, 12 times 15, 115, 180 then. Alright, so that'd be 180 pi. And then, since they're saying leave it in terms of pi, you don't have to multiply the pi, you can just leave it there in a symbol form and add your 72 and your 180 together, you're going to get 252 pi. And then you would also add on your label, centimeters squared. Alright, let's try one more of these. So this time, let's say we had, I think I have these examples. Let's see, so the next example, we have a soup can is 4.5 inches high and has a diameter of 3 inches. How much paper is needed to completely cover all sides of the can without overlap? Okay. So, they tricked me. I thought they were going to talk about the label. Let's go ahead and use our formula. So we have the surface area again is 2 pi rh plus 2 pi r squared. And that's our formula for the surface area of a cylinder. Let's fill in our numbers. And before we do that, I'm going to draw a picture. So in our cylinder this time we have a soup can. They're saying it's 4.5 inches for the height and the diameter. So this time it's a little different. Diameter would be 3. So from this one through the center all the way to the opposite side, that's 3 inches. Okay. Well, the radius is always half the diameter, so that'd be 1.5. So when we're plugging this in, we'd say, hey, the surface area, the radius is going to be 1.5. So we have 2 times pi times 1.5 times our height of 4.5 plus 2 times pi times the radius, which would be 1.5 squared. Okay. Let's go ahead and type this in. So we have on the right side here 1.5 squared. Well, that's just going to be 2.25 because 15 squared is 225, so 1.5, yeah, it's going to be 225. Double that, you're at 4.5. Alright, so 4.5 pi on the right. Let's check out the left side here. So we have 4.5 times 1.5 times 2. Okay, so 1.5 times 4.5, and double that up, you're at 13.5 pi. So 13.5 pi plus your 4.5 pi, you're going to be at 18 pi. And the label would be inches squared. Alright. And here they don't specify whether we need to leave it in terms of pi or not. So let's say we didn't know, or they did want us to multiply pi, then you just say 18 times pi, enter, so you could say it's 56.55 inches squared. Alright, there you have it. We covered a couple examples with surface area of rectangles, or prisms, rectangular prisms, triangular prisms, and cylinders. I hope this helps. Good luck in your practice.